So this is the second half of day one notes, and we're going to be talking about how you do adding and subtracting of radicals. You may or may not have done some of this radical work previously, so some of it you may have seen before and you may be a little bit more comfortable with depending on your teacher. So if we're adding and subtracting radicals, radicals must have a common radicand in order to be added or subtracted. And radicand, by definition, is whatever you have underneath the radical. So what's underneath the radical is called the radicand. In a way, radicals are like fractions, where you have to have a common denominator to add and subtract. We have to have a common radicand here in order to add or subtract these. The rules for adding or subtracting radicals are that we want to simplify the radicals first to determine whether or not that radicand is common and whether or not they can even be combined. So I'm going to start with question number one. And when I take a look at question number one, I can see that they already have matching radicands, and technically the radicand or the radical is simplified already. So I don't have to do any simplifying here. I can skip step one and go right on to step two, which is to combine terms with common radicands by adding or subtracting the coefficients. And that's going to be what's in front of the radicals. So if I'm looking at this, and in the first one I have 7 radical 5s and I add 3 more, that tells me that I have 10 radical 5s total. For question number 2, the same exact thing happens. In this I have 4 radical 3s and I'm technically taking away 1 radical 3. It's like an x where there's an imaginary 1 in front of it. So 4 radical 3s minus 1 radical 3 will give me 3 radical 3s. And then I'll have you flip the page. When you go on to the next page and you take a look at, let's say, question number 3, you can see already in question number 3 the radicals don't match. I am going back to step 1, which says simplify the radicals that you can. It is not possible for me to simplify this radical 2. It's simplified already, but radical 8, I know I can break up into 4 and 2. And the reason why I'm picking 4 and 2 is because the square root of 4 we know is 2. So technically now I've converted that into a radical 2 term. So the first term is 1 radical 2 plus 2 more radical 2's, which gives me 3 radical 2's all total. So final answer here, 3 radical 2. Sometimes they can mix in some variables underneath there with the exponents on them. The same rules apply. So when I look at question number 5, in question number 5, when I do this one, I want to simplify both of the radicals. Radical 200a squared, I'm going to split into 2 parts. I'm going to do 100 in the first radical, 2 in the second. That's how I'm splitting the 200. And then a squared, I'm going to put over here because a squared is a perfect square. And then I have to simplify the second one. Remember, there's a minus sign between them. And when I simplify the second one, 18 I'm going to split into 9 times 2. I use 9 times 2 because 9 is a perfect square. A squared is a perfect square. And then I'm going to go back and simplify. So I've split that into 2 parts. I'm going to go back and simplify now. Square root of 100a squared is 10a. Radical 2 stays. Square root of 9a squared is 3a. The radical 2 stays. Now I have 2 terms that both have radical 2's in them. The coefficients also match. They both have a's in them. So I can go back now and subtract. So I'm looking to see how many radical 2's I have. I have 10a of them minus 3a of them, which gives me 7a radical 2. If we move on to a question like number 7, there's 3 terms that we need to try to combine here. So when I do question number 7, I have to simplify all 3 terms. So I've got to simplify this one, and I need to simplify this one, and I need to simplify this one. So I'm going to simplify them, and then I'm going to go back and see if I can combine them. So for the first one, radical 8, I know I'm going to do 8, I'm going to do 4 and 2 when I simplify that. And then the middle term, I've got a 24 there, which to do 4 and 6. And then the last term, 32. Some of you may be tempted to do 4 and 8. I'm going to do 16 and 2 because 16 is the largest perfect square that goes into 32. And then I go back and I simplify. So when I go back and simplify, I've got a 4, which is times the square root of 4, which is 2. Radical 2 stays, it's irrational. Plus 5, square root of 4 is 2. Radical 6 stays. Minus square root of 16 is 4. Radical 2. I have to go back now and multiply what I can, so this gives me 8 radical 2 plus 10 radical 6 minus 4 radical 2. And I'm looking to combine the terms that I can combine. One of the rules we started out with today was talking about how you have to have like radicands in order to add. So that means that the only two that I'm allowed to combine are going to be these two, because they're the ones with the radical 2 in them. 8 radical 2 minus 4 radical 2 gives me 4 radical 2 plus I also have a radical 6 over there that I'm going to add on. This is my final answer here. I cannot go back and combine those two together because the radicands do not match. So on here, I'm also going to go back now and take a look at question number 9. So I'll do question number 9 with you. In question number 9, same exact process. Everything needs to be simplified before we can go through and combine like terms. So I've got to make sure that I simplify this. 9 out front stays. 9 itself under the radical is perfect square, and s squared is the perfect part of s to the third, and s to the first is the not perfect part. So every time you do this, it's a matter of going through and breaking everything down in order to simplify it. And then we'll move on to the middle term. So minus 6, it stays there. I want to simplify and find out the perfect part of what's under the radical, so 25 is perfect. S to the second is not, and there's an extra S. S to the first if you'd like. And then I move on to the next one. I already have an S out front. The 16S under the radical, 16 is perfect, S is not. So I've broken everything up. Now I go back, combine things that I can, square root things that I can. So when I go back now and do this, I have over here the 9. I can square root this, so times 3s. And there's a radical s at the end. I can't do anything with that. Minus 6 times 5s radical s plus square root of 16 is 4. So I'm going to write this times 4 and put the s over here. Radical s. So if I go back now, multiply what I can. Way back to the beginning, I'm going to start over here. That's 27s, radical s. And then go to here, minus 30s, radical s. And then go to here, plus 4s, radical s. I can see that all of my terms have radical s's in them. So they're all considered like terms as far as, oops, I should have done this one. As far as that's concerned, they all have radical s's. And in addition, they all have s's in front. So their coefficients are matching terms as well, which allows me to go back and combine them. So 27 minus 30 is negative 3, plus 4 is going to give me positive 1 s radical s, which we would just write as s radical s. So after all of that, our final answer is just going to be s radical s. I am going to do another video where I go back and fill in all the questions I did not do if anybody needs extra practice. So a third video will go with the first lesson where all I've done is gone back and done the ones that I did not do the first time through. So it's optional if you want to watch it. If you need extra practice, I strongly encourage that you do take those notes and take a look at how to do some of those problems.